Okay, as we continue through our review here, secondary trig ratios. It's technically not in the curriculum, however, you're going to come across it in college, and often graduated students come back and say, "Gee, I wish you would have mentioned it." It is in the textbook homework, so I am going to make you aware of it. So secondary trig ratios, there are 3 of them, and we have cosecant, secant, and cotangent. Let me just space that out a little bit. And they are what we call a reciprocal function to our primary trig ratios. So for example, cosecant of theta, so cosecant is CSC, it's really just equal to 1 over sine theta. All right, that's all it's doing. It's just a division so that they don't have to carry fractions through when they do calculations. It's really the only reason it's come forward, because you don't, in order to calculate, you still have to use sine, cos, and tan. All right, so it's a second, we call them a secondary trig ratio, and they're just the reciprocal functions for the ones you already know. So cotan is cot theta, and it's just 1 over tan theta. Okay, so just a quick example, if you have to calculate with it, so it'll just be calculate the ratio, calculate the ratio. Here we go. So example 1, cosecant of 50 degrees. Well, there's no button on the calculator that's going to do this for you. You have to manually switch this to 1 over sine theta, sine 50, I should say. And then with your calculator, do 1 divided by 50 sine. All right? And you should get 1.31 roughly. Okay? So just one more example with that. So if I give you, or if you see secant 80 in the textbook, then you're going to put 1 over cos of 80, and then it's just 1 divided by cos 80. So like I said, the only reason that they did this is so that they didn't have to carry through fractions in some of their calculations. All right, so rather than going through and carrying 1 over cos 80 through in the calculations, they don't like fractions. So they said, let's just write it like this. And secant simply means it's 1 over cos theta. So I would recommend, make sure you put this on your cheat sheet. And make sure you have it handy as you work through the homework. That's not what I wanted it to do, but that's all right. Emphasizes the point, okay? Just so it's a quick reference, just so you remember what they are. Okay, determine the missing value. So we are now into a obtuse triangle. It doesn't have to be obtuse in this case. So what happens if I have, for example, 4, and we'll make this one 35 degrees, and over here we shall make this a 7. All right, and we'll do measurements in meters, and I want to find x and y. So in the grade 11 course, you got introduced to what we call the sine law. So this is a sine law question. All right, so just as a review, sine law, the formula for sine law is side A divided by sine A equals side length B divided by angle, sine of angle B, C over sine C. So this definitely needs to go on cheat sheet. All right, it is a formula we will be using. All right, so first thing you want to do is you want to label the example triangle here as A, B, and C. Remember that the sides are labeled such that this would be small a, this would be small b, and this is small c. So what I recommend when you know it's a sine law question, and a sine law question is the first one you check when it's not right angle because it's the easiest. What I do then is I take that formula and I plug in the information that I have. So for example, I would have from my formula y over sine of angle A equals 4 over sine of B, so sine x, and it's also equal to 7 over sine 35. All right, so there's 2 unknowns that I'm looking for. Can I find any of them off the start? And the answer is yes. If I take these 2 fractions, there's only one unknown, and that's the x. So I'm just going to group those I'm going to go over here with it. So I'm going to have 4 sine x equals 7 over sine 35. I want to get sine x by itself. So what I'm going to do is I'm going to multiply this side by sine x. I'm going to multiply this side by sine 35. Inverse operation. So those would cancel out. Oops, but I also have to multiply this side by sine x. So maybe let me go back a step and avoid confusion. Well, I don't want to close that though. So keep going back. Okay, let's try this a different way. The variable's on the denominator. Okay, sine x on the bottom. I'm going to flip both fractions. So now I'm going to have sine x over 4 equals sine 35 over 7. This is probably a less confusing way. So if the variable's in the denominator, flip both the fractions on both sides. I want to get x by itself, multiply this side by 4, and this side by 4. Those will cancel out. So I'm left with sine x equals 4 times sine 35 over 7. So I'm going to calculate that value, but I'm going to just write it like this because I don't want to write out the decimal. You're going to have the decimal on your calculator. Don't write it out. So using your calculator, you get a value of 19.1. And it's an angle, so it's in degrees. Okay? So you now know what the value of x is. All right, so there's your x value. Again, this is review from grade 11, so if there's areas of concern, make sure when you're doing the review work, the homework, that you clarify it. So I now know what this angle is over here. I know that it's 19.1 degrees. Now I want to find the value of y, so I got to find that third angle. So I can find angle A now, because if I know 2 angles in a triangle, I know all 3. So the missing angle, angle A, is equal to 180 degrees in the triangle. Take away 35, take away 19.1, and you get 125.9. So now I know that angle is 125.9. I then can go back to my sine law, and I can pick a different pair of fractions here to solve for. So now I'm going to take this fraction and this fraction. I'm going to take them over here. I'm still looking for the value of y. I now know the angle of A. It's 125.9. And I got it equal to 7 over sine 35. In this case, the unknown values on top are in the numerator, so we don't have to flip the fraction. So now we multiply both sides by sine of 125.9, sine 125.9. We do that for inverse operation. So now we get y is equal to 7 times the sine of 125.9 over sine 35. So now we can go ahead and make that calculation. And again, you need to know how to use your calculator, so please make sure you are using a calculator that you plan on having at the end of the year for the exam, because with trig, every calculator's got some different quirks. So again, this is the review of the sine law. Same as it was last year, so please be aware. It is now assumed known knowledge, so make sure if you're not sure with the sine law that you take some time and do some practice. Okay, what happens if it's a different combination? What happens if the sine law, there's not enough information? So we end up with 6 meters, 12 meters, and an angle of, let's say, 105. And I want to find x. If you go and label the triangle, A, B, and C, and let's say, for example, you think you can use sine law here. So for the next segment, don't copy this down because I'm going to erase it. So you say, okay, I'm going to use sine law. Sine law is A over sine A equals B over sine B equals C over sine C. Plug in the information I have. 6 over sine A equals 12 over sine B equals x over sine of 105. So what happens I don't know all the information there. I don't know all the information there. And I don't know all the information there. So what that means is I don't have enough information. In the previous example, I had one fraction where I knew everything. You need to have that to use sine law. None of these fractions that I'm looking at, okay, have all the information. So what that tells me is I made the wrong choice. I should have used the other function, and that's the cosine law. All right, cosine law, again, from grade 11 course. Cosine law is a squared equals b squared plus c squared minus 2bc cos of angle A. Again, this goes on the cheat sheet. It is required information or known knowledge. So I know this is the formula I want. Now mine I need to adjust because the unknown is actually across from c. So the formula I'm going to use, I just move the c to the other side. So c squared equals a squared plus b squared minus 2ab cos c. Now I plug in my information. So side c is a length of x squared. A is 6 squared, b is 12 squared, minus 2 times 6 times 12 cos of 105. Now it's just a matter of plug and chug. You've done the thinking. Now it's just calculator work. Please remember this and this have to be calculated either separately, or if you have a calculator that handles it all at once, that's fine. But you cannot add those terms together until the cos 105 has been punched into the calculator and a value found. All right, so as you punch it into the calculator, I'm going to go a long way with this. Minus, and when I punch that in, 2 times 6 times 12 times cos 105, I get negative 37, so I'm actually adding 37.3. So x squared equals 36 plus 144 plus the 37.3. So I get 217.3. Please remember, with cosine law, when you're looking for a side, you do need to take a square root. So we get x equals 14.7 meters. And there's your final answer. All right. So as you work your way through, all the questions that are assigned in the homework for this section right here are dealing with a review of the grade 10 trig. I'm going to do one more video to finish off this word problem, and really the only thing I'm worried about is angle of inclination and angle of depression. So it'll be a very short video on that in that final example.